This problem says find the zeros and their multiplicities for the polynomial p of x equals 3x minus 4 times x plus 2 cubed times x minus 3 to the fifth. What we want to do here is apply the zero factor law. When we're looking for zeros of a polynomial, we set the polynomial equal to 0. And since a product of these things is set equal to 0, it must be the case that at least one of them has to be 0. So we set each of them individually equal to 0. And then we can solve for the zeros. So just do a little algebra here. One of our zeros is 4/3. In order to get rid of the cube, we would simply do a cube root. Because we're going to be taking a cube root of 0 here, that result is just going to be 0. So basically the cube is not going to matter when it comes to finding the value of the 0. -2 is a 0. But because there is a cube on the x plus 2 factor, that means we have a multiplicity of 3 for that factor and for that root. Same thing applies here. Take a 5th root of both sides. The 0 in this case is just 3. And the multiplicity is going to be 5. And another way to think about that multiplicity is if you were to write it all out, you'd have a repetition of the root of -2 3 times. Okay, so we have one appearance of the 4/3. We have 3 appearances of x equals -2. And we have 5 appearances of x equals 3. Now we could go to a graphing program and take a look at these roots. So just type in the polynomial. And what we'll see is that we have a root at 4/3 and -2. If we were to raise the multiplicity of the -2 and make it a multiplicity of 2 now, what happens is it still touches at -2, but it doesn't cross through the x-axis. But we're going to raise the multiplicity here to 3, and now it actually will go back to crossing through the axis. So when you have an even multiplicity, it won't cross through, but if you have an odd multiplicity, it will. And then we'll do our x minus 3. Now we've got 3 roots, And let's raise the multiplicity of that x minus 3. We want to raise it to a power of 5. So here are our roots: -2, 4/3, and 3.